let's take a look at our last task for the day, which is globalized call routing using H323 intercluster trunks. So what we're going to do now is bring in what we drew on the whiteboard initially, which was another cluster, another CUCM cluster. And this isn't another proper CUCM cluster, although it only has one phone and no gateways in it. It's just emulating what another cluster might look like and how we would do intercluster trunks and digit manipulation, sending back and forth. We're told to create an H323 intercluster trunk between the two CUCM clusters using the G711 codec. We did this essentially as far as the G711 codec mainly because we didn't want to have to go provision MTPs or transcoders or anything else that might possibly be needed depending on what we use in terms of clustering on the other cluster. So G711 just to make it easy. More concerned with the call routing and the globalized format of the numbers. So we're told to do what's necessary to ensure that users in both clusters are able to use abbreviated dialing to reach users in their own. Now, abbreviated dialing could be understood by you as what we did earlier, where a user presses 1 and then hits abbreviated dialing, or 2, basically what they've set up on their own CCM as abbreviated dialing. Cisco in the SR&D also refers to abbreviated dialing in the format of 4-digit or 5-digit or whatever the extension length is of DNs on your cluster, just dialing with 3 or 4 or 5 digits as an extension length. They also refer to that as abbreviated dialing. So that's what we're referring to here. Real lab, if there's any confusion, that would be a perfect time to ask the proctor what they mean by that. So anyway, they should be able to, users in both clusters, use abbreviated dialing to reach users in their own or the other cluster. We're told to globalize any abbreviated DNs not registered with the same cluster and to route all these globalized numbers to their respective clusters over the ICT trunk as follows. ICT trunk, right? So belonging to the I&E cluster are the DNs of 1000 series, 2000 series, and 3000 series. So these are what will need to be created on the partner cluster, but they belong to the I&E cluster, and we're given the format to globalize them with. Belonging to the partner cluster, which globalized and routed on the I&E cluster, over to the partner cluster is the 5000 series of numbers, and they're globalized to +61, 2, and then 8 digits, 9254 and 5XXX. Okay, we're also told to ensure that all calls from each cluster are load balanced between the servers listed below. So the I&E CUCM cluster has a publisher at 177.1.10.10 and a subscriber at 177.1.10.20. And the partner CUCM cluster has a publisher at 177.1.10.2.10 and a subscriber at 177.1.10.2.20. Then we're told that, as noted in task 11.1, all users' phone listings in both clusters' corporate phone directories are already populated in E164 format. So from the I&E cluster, look up Charles Widmore and ring him. And then from the partner cluster, look up Desmond Hume and ring him. Okay. So let's take a look, first of all, and set up the intercluster trunk. Let's go ahead and log in to the other cluster here. That this looks fairly similar, but there's only one phone registered in the Sydney headquarter device pool. Okay, so just to contrast, here's our phones in our I&E cluster. So let's create our intercluster trunks. By the way, let me go back. You see 3 SIP trunks for corporate headquarters. They all look like they're the same exact trunk. They are. The reason it shows up like this is because they're priority 3, 2, and 1 in route groups branch 1, branch 2, and corporate headquarters respectively. So because they show up in multiple route groups, gateways here real quick. Gateways don't show up like that. But the trunks, because they show up in multiple route groups, it shows up 3 times, but it is only just the one corporate headquarter gate. Okay, so we're going to create a intercluster non-gatekeeper controlled trunk, which is H225 or H323. Device name, we're going to call this the partner ICT to, let's say, to the sub, and put this in our, we're actually going to need, just to make sure that it is in fact .711 all around. Actually, I think our MOH does that already. Create a new region. We'll call it region underscore partner ICT. Say that to all other regions, it explicitly is G711 only. Create a new device pool to correspond. Really care about, put something in for time, really care about is the region. An asterisk reference, we have to put something in, but other than that, we don't much. Then we'll go back and you might say, why am I putting in the word sub here? Because Mark, don't you know that as you scroll down, I can put in up to 3 remote IPs. So I can put in sub, 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 or sub pub, or whatever. Well, I can. However, it's going to always try the primary one, and then if it's down, then try the backup. This is not scalable. Well, it's somewhat, I suppose, scalable. It's not efficient. It's not really scalable very far, and it's certainly not going to meet the requirements of load balancing. In order to do that, I'm actually going to need to specify here on my INE cluster, my .10. So I'm going to specify the IP address Now I'm not going to globalize, or I'm sorry, I'm not going to strip significant digits here because they might want to do THO later. That's not going to be part of our tasks, but who knows, they might want to do that. So calling search space does need to be something that can route to internal DNs and possibly out to the PSTN. Back to this bit later. So for right now, our location hub, that's good. We've got the device pool set for G711 only. Created this. We're going to create another one. Space has to be able to route. Really should have an AAR calling search space just in case we're trying to route over to a number that is not local to whatever site we're at, which here we happen to be location hub none. And if we take a look back, the device pool is actually set to corporate headquarters. Device pool location, which is set to hub. And if we're trying to go over to branch 1 in AAR, this trunk here would invoke it, so it does need an AR, CSS, and group. We'll go back and add that to okay. So we've created the trunk here. Let's go create the trunk on the partner side. Now there's actually only one region default, but there should only be one device pool. Oh, you know what? Whenever you import, it's always going to keep the default, doesn't delete it. So there's the default, but then there's the Sydney headquarter, and we're just going to use the same device pool, so same region on the trunk as the phone has. Okay, so we'll create a new ICT non-gatekeeper controlled. Device name will be sub. Okay, we're not going to set anything else because we really don't have anything else set up like a. I don't even have any calling search spaces. The phone that we do have is has a DN of 5001, but it's in the null partition. Okay, and so the IP address of .10. Oh, sorry, this was the sub, so .20. So it didn't save properly. There we go, add successful. Hub. Okay, so now that I've added these, set them both sides. In order to make them load balanced, I need to create on each side a new route group route group will have circular functionality. It really doesn't matter which one I place first because it's going to send call 1, call 2, call 3, call 4, call 5. So this, and of course create route list. Route list to INE ICT. Route list. Okay, so I've got my route list. One route group, which is circular. Make sure I'm pointing to my two trunks. Okay, need to do the same thing on the INE cluster. We've set it up on the partner cluster. circular, do a save, list, group, route list. Okay, so now we've got the trunk set up on both sides, the circular route group set up on both sides, the route list set up on both sides. It's time to create patterns. So from the partner side, let's create a pattern. Shouldn't have any patterns. And we'll create the pattern, and it will be 1, 2, or 3 XXX. There are no partitions. Route list. We don't really want to provide outside dial tone. Urgent priority, well, that's actually the only thing that's going to be matched anyway. So we probably don't care. We probably do want our external phone number mask. Now let's actually take a look at that. One phone we have has an external phone number mask that has a 0 as a preceding, 2, and then 8 digits. So we actually want to strip off that 0 and prefix on the country code of +61. So we want to prefix +61, or mask is actually going to need to be 9 digits because currently 10, and we don't want that preceding 0. So 1, 2, 3. Properly because I opened the tab. There we go. And it's checked. Again. All right. There we go. Okay, so now we have one pattern that should route calls over to the other side. Now, if we try to route calls over to the other side, remember that on these ICT trunks, we just briefly so that we can see if calls will route first. Set these. Okay. We'll give those just a second to reset. And once those reset, our phones, actually we'll tell one of these phones to or anything like that, which let's take a look. Registered. Does go to stability, make sure AXL is started. There's actually no subscriber running right part of the task, but it's actually not really running. AXL is running, call manager is running. Go. Just about registered. Go. Up, and hopefully, there we go. All right. So a simple restart. Currently, let's try calling one direction. Widmore. And the call, sure enough, rings over to Jack Shepard. Now, note first of all, it shows Jack Shepard at 1001, which maybe that's what we want. Charles Widmore shows up with 6129254 5001. Doesn't show up with +61. Now, wait a minute. Here we're on the .210, so the partner cluster. When we created our pattern, we did create calling party's number, mask, 9 X's, and +61. So where did the plus go? So the plus got dropped at the inbound trunk. You might say, why? Well, inbound significant digits 4? No, because that's for call-ed. That's DNIS. We're looking at A and I, right? If I do that call again, this is the terminating phone. This is A and I. This is who is being called. I'm looking at the calling number. Who's calling me? Answer. That wasn't what did it. That truncated DNIS to allow the call to route. And we don't have any, well, actually, let's take a look. The phone that was being rung, Jack, which was corporate headquarter phone 1, has a calling party transformation CSS as used device pool currently. Device pool for corporate headquarters has anything set? Actually doesn't have anything set. Should have had something set, but for whatever reason, maybe it didn't import properly, it doesn't have anything. So if there's no CSS, then the only calling party transformations that can take place are ones without partitions, which is a really bad idea. So even if we did, then it would be the corporate US phones for plus, and that would strip off the plus with pre-dot and add 0 and 1, but that's not what we're seeing. 61 instead of +61. H323 currently doesn't support the plus character in either calling or call-ed. It's just going to strip it off. It doesn't not route the call when you send it, or else, of course, the call wouldn't have routed. But it is going to strip it off. Now, we were also told to, well, first of all, before we go on, so how could we add that back in? Well, how about on these that we use the same thing we've done with every inbound gateway, which is to prefix plus party And because we don't know exactly how the sending or originating CUCM cluster is going to format that calling number, mainly because we don't have any sort of numbering plan utilized or route filters with which to make the decision, and CUCM might choose something arbitrary or might choose nothing at all and leave it unknown, we'll just add a plus to everything. So, we save, set, we'll do it to the pub as well. Now let's try that call again. Now we should, there we go. Now we see the plus 6-1. So H323 stripped the plus. However, we can add it back in. What about, back and look at the task, we were told that do what's ever necessary to ensure that both clusters are able to use abbreviated dialing, globalize any abbreviated DNs not registered with the same cluster, and then it says to route the globalized numbers to their respective clusters. So we were told to globalize it. If we do a redial, this only shows up 1001. It does not show a globalized format of 1001. If we wanted to globalize the number, over here on the partner, we wouldn't just be able to do 1, 2, or 3, and then 3 X's as a route pattern pointing directly to the route list. Of course, that's the simplest configuration, but remember, if this were a whole nother cluster, it would be properly globalized as well. That's the whole idea of what we're talking about today, is having not just one, but any and all of our clusters in full globalized format. And so in the same way that our INE cluster, route patterns only begin with plus, and typically there's one, maybe a few for the reasons of THO, we need to also have a single \+ bang partitions pattern with urgent priority checked, pointing to that one ICT. Granted, there would be multiple might be multiple possible route patterns and route lists, or our standard local route group, and the route group chosen by that might contain the route groups for ICT. We'd probably have another pattern, but the idea is that we have everything fully globalized. If this were the case, we cannot modify this number to globalization and route it right back. Route patterns only point to route lists. So we're actually going to delete this. We're going to create it as a translation pattern. And we're going to do them separately. One XXX, calling search space because, well, there are none. And we're again going to use calling party's external phone number mask. +61, actually doesn't really matter plus or not. Side. But then we're going to have the called party transformation mask set to +1 206 501 1 XXX, or actually could have simply done fix to the existing. Then we'll copy this for 2 512 602. Then we'll copy it again for 3. 120.703. 03. Now we've got three translation patterns that globalize the calling and call-ed and then route those via their CSS, which is none, to the partition, which is none, anything that contains a plus. We, of course, have calling search spaces and partitions in a proper network, but we don't here, so our one pattern should route everything out. Let's try. Go off hook and dial, let's say 1001. It does. Now it still shows to 1001. Why is that? If we had transformed the number, then why does it show it to 1001? Any ideas? Well, it's actually because H323 carries transformation of the DNIS back to the original calling party. Over on the INE cluster, on the trunk, we had translated or transformed down to the 4 most significant digits, or digits from the right. So if I brought this back up to all digits, that now we're probably going to have a little bit of a difference here because the call won't route, but we should see with a redial, we should see the plus format. Now it didn't route because it got over to the other side and didn't match anything, but the proper format we saw for the plus number. Okay, so here on the INE trunk, what would we need to do? Well, first of all, if we wanted to keep that number in a globalized format, let's take a look back at our, there they are, translation patterns on the INE cluster. And if you recall, we had the internal directory that would allow us to see this DN as a match pattern \+12065011000 series and transform the called party down to 4 digits. Well, that was exactly what we wanted. That's great, right? The only problem being that, first of all, does this cluster side of the trunk, it has the inbound calling search space of device US PSTN. Look and see, does that US PSTN contain the internal directory? It does. Okay, so then why didn't it get to that translation pattern and match and truncate it down to 4 digits? Because remember, the plus was stripped. So even though we translated the call-led number on the originating gateway side, partner cluster, we translated it to a plus number. That worked for getting it to its route pattern with a plus, but the plus is stripped for calling and call-ed. So we need to reintroduce the plus. And you might say, but wait a minute, on your, and we're still on .10, so the INE cluster, on this side of the trunk, you added the plus. Well, that was added to calling, not call-ed, or called. So we actually need to set up partition in CSS. Call this partition ICT globalize. We'll create a new CSS. Of course, don't have to keep the names the same. Great. Okay. So now I've got a new CSS containing the new partition. Let's create a new translation pattern. Basically takes everything in the globalized DNS. So it matches everything, globalizes, or it prefixes the called party with a plus. That's it. Urgent priority is definitely necessary. And the CSS it'll route on to is going to be dial device US. Right, and now the trunks, those are, instead of importing into using the traditional calling search space of dial device US, they're going to use ICT globalize. We need to do this for AAR as well. That's correct. We wouldn't, because that DN is obtained local information here. So the AAR mask of whatever phone is trying to be dialed. Not want to do that, or else we'd be adding 2 pluses. Bad. All right, so we're going to add a plus to everything. We'll say save. Yes, we know we need to restart or reset. Reset. Go back and do this to the same as the other side. Okay, so we've reset those. We should be globalizing all inbound numbers based on this CSS that can only see one partition, and only that partition is only one translation pattern that matches everything and prefixes a plus to all called party numbers. All right, so here's still our INE cluster, and here's still our partner cluster. So now let's try this call again. No, it rings, it shows up. Now it shows up again as 1001. Why is that? Because, again, the translation pattern over here on CUCM, not this one, that was the one that added the plus. And what did that do? Its CSS then took the plus and tried to match anything. Well, it sees a lot, but the most specific is the one in the internal directory, which translates it back down to 4 digits. So what's the reason we're doing all of this? Simply so that we know that we can use not only a corporate directory, but any form of dialing that both clusters support fully globalized dialing beginning with plus. And any calls that come from either side, either cluster, will come in the format, if it's H323, they will come in the format of country code first, so we need to add the plus always, and then the call will be able to be routed anywhere. It might not just be out to a phone where we're seeing a specific DID plus DID match and then truncating it down to 4 digits and routing it to an internal phone. It might be out to an egress gateway. Everything will be in the exact same format. It's standardized, it's normalized, we know what to expect, and so we can format it properly on the egress. Now what if we wanted to see Charles Widmore, what if we wanted to see 4 digits there as well? Well, in that case, 5001 Charles Widmore. Why? Because this was where we were getting, this was the dialed digits, well, eventually where it ended up, and we're transforming the calling party to 4 X's, or the 4 most significant digits of their calling party is formatted as. Certainly do that as well. Now if I try to call, let's say, 5001, Desmond sees me as coming from 5001. I see him as 3001, even though the number has been globalized and then localized. So what about the corporate directory? If from Charles' phone I look up and I see any of these numbers, I can choose, let's see, option 2, Desmond, and try to route the call. That should route as well. Now, why is that routing, and why did it show me 3001? We just talked about why it's going to show you 3001, because the translation pattern on the far end terminating cluster does the truncation of the call-ed or DNIS number. All of that information gets carried back through H323. Now, I'll tell you, a forwarded call, that information might not get carried back, but a translation pattern is going to be transparent and is going to get carried back through H323. But a forward should actually get carried back through H323 as well. Show up as a forward, I guess, was my point, not a dialed digits or DNIS. Okay? So why did it actually ring when we dialed the plus? If we're over here on the partner cluster, let's go take a look at our entire route plan report. Because there is a plus pattern, because there are no partitions or calling search spaces, the phone can see this pattern, dial it directly. Now, if we wanted, specific ANI or specific calling party transformation based on dial digits, that's where this cluster would be fully populated. Oops. That's where this cluster would be fully populated, just like our far end terminating INE cluster that we've been working with for a while, just like it's fully populated with a bunch of /+ translation patterns as well. But we're just doing this for the sake of example. All right, so we haven't done it the other way. That is to say that the INE cluster cannot dial 5001. So let's add that functionality. Same thing, we'll create a new translation pattern on the INE cluster, 5XXX. Have it able to see dial device US PSTN. We don't want to provide outside dial tone. Urgent priority probably isn't necessary. We'll use calling party's external phone number mask and prefix a +1. Now we would actually need to put this in the US dial device and then one in the, create a duplicate in the Netherlands, because our calling party is going to be formatted differently if we wanted that to show up on the other side. If we didn't care, then in this case we really don't, we're just going to be localizing it. If we were doing this to not just 5XXX but also to potentially users that wanted to see the plus dial as their display. Or if we were sending it out to a gateway there, creating a pattern to send it out to a gateway. Right now, the called party transform mask will be, prefix will be +61 2 9 4, and then that's it. So prefix globalizes the number. Now we've got things that route those global numbers. They are called PSTN patterns. However, we don't want to route it out through the PSTN. We want specifically, so we could create a new translation pattern here, or actually tell this 5xxx, globalize it, but then to send it on to RP SLRG, or translation pattern to route pattern, standard local route group. So this will send it on to our route patterns. Route pattern here, because we have to have a new route pattern to point to the trunk. Route pattern will be \+61. Really, we could just route anything to \61 over, knowing that if it gets over to that other side, maybe it was sent by a 5xxx route translation pattern, or maybe it was sent by one that wanted to route calls out to gateways there. So we'll just say and we don't need to mess with any of these calling or called party transformations. All that's done at the translation pattern level. All right, so let's see if this works. Now it probably won't. Actually, I can. Oh, and it does. But does it 5001? Okay, so here's 5001. It does fail. Now remember, this call is getting into the 210, or the partner ICT trunks and cluster. Coming in here, and we did not say significant digits 4. Now there is no CSS, so we don't need anything special there. But we do have to say either significant digits, or we have to come up with something to localize that number. Now again, remember, we didn't globalize the number. So we would probably, if we were doing this full on properly, and why don't we just go ahead and do that, create a globalize space capture that. We'll create a translation pattern that all numbers, but only in, and sends it on to plus to the DNIS. Back to our trunks. Prefix the plus. Tell the inbound call lead, or DNIS, out to that ICT. Set. trunk. Make sure that these were actually properly load balancing over to the INE sub and pub. We could pull up RTMT. Now we're globalizing the number, that translation pattern, but now we have to have something that matches the globalized pattern and localizes it, right? We've been through this. So backslash plus 612, and then 4, 5, XXX, globalize the called party to XXX, should allow the call to route. So the call comes in from the trunk, hits this, adds a plus, and loops around, hits this, and goes down to 4 digits. Again, the reason for this, rather than just having significant digits 4, is what if we wanted to have international intercluster tail end hop off? Everything needs to be in the not, it's going to be much harder to deal with. All right, so let's try this again. Now the call rings across, sets up. Now we see +1, 1001. That's interesting. That. Let's see. I know why the plus is there, because we did that on the called party, or the terminating trunk. We added the plus. Over here on the originating, happening. Oops. 5 XXX, and we also, because we're prefixing +1, right? Calling party's external phone number mask. Go. Dial. Now it shows up as the full number. Again, if we only wanted to see 4 digits, far end, terminating gateway, calling party mask, or now that same call, or here, 4 on the original gateway. The only thing we forgot to do was right now, corporate headquarter and branch 1, both sites in the US can dial, but Desmond cannot. Replicate this. Site. Well, try our final step that we were instructed to do from both sides and do corporate directory from both sides. Okay, so last name is Widmore. Charles, let's dial Charles. Still routes across just fine, and even gets shown that it's only a 4-digit dial ultimately. Back the other way. Going back the other way. Now we've got fully globalized corporate directory, intercluster, got all DNIS and ANI being properly globalized before it goes out to the egress, to the terminating gateway cluster or trunk, and ANI also before it goes out, but then once we get over to the other side, we have to add the plus back into both sides. Now, you might say, you know what, with this new globalized format, that's just a lot to do, is that extra adding the plus on both sides. It's kind of a pain. The way we can get away with that, or from that. And the answer is yes, there is a way that we can get away from having to add the plus. And it's called don't use ICT anymore. H323 strips that. What doesn't strip that is zip trunks. Also, with ICT, I was able to use a IP address or a host name. With SIP, I can not only use a host name, but I can also say that the destination address is a service record, an SRV DNS record, a service record, which gets rid of port as well. And I don't need to know about port, so I can use non-standard ports other than 5060, which is helpful because maybe I want to have security and I don't want to use standard ports. But with service records, just like mail records for email, MS, I can have essentially kind of a mini cheap load balancer working. So I can either have all of my service records, all the different hosts that are serving that protocol and service. So the service would be SIP and the protocol would be TCP or UDP. So it would be written as like underscore SIP would be the service, underscore TCP or underscore UDP or possibly both as the protocol. And then I'd have my priority, lower priority is better. I could have them all the same. And then I can also have weight. So for priorities that are the same, how much of the load proportionally, in a ratio, how much of that weight or overall load do they share? So I have a lot more flexibility and functionality. I don't have to create multiple trunks and put them in a separate, into separate into separate route groups that use circular and therefore create their own route lists and their own patterns. They could be added as just one more gateway or one more route group in a top-down route list to standard local route group and get all calls over and still have true load balancing. I don't have to create as many entities. And with SIP, although I only have one incoming calling prefix, you might just say, yeah, so I just prefix everything to plus. How about you don't prefix anything to plus? It's just known and understood and discussed ahead of time that both or all clusters that are essentially fully meshing together by only creating one SIP trunk to every other cluster will fully globalize both their calling and call-ed numbers prior to sending. And if I know that, my part or colleague, peer that's working in my Japan cluster and another one that's working in my Australia cluster, another one that's in charge of the EU cluster, everyone has talked and we've understood that we will be fully globalizing both calling and called before we send, and we're using SIP, which doesn't strip the plus, then I know that I can treat calling and called in the exact same format when it gets to the other side. So we looked at ICT, which was H323, mainly because we wanted to understand the limitations and kind of the drawback to using those. But the way forward with CUCM is SIP, especially for, in this case, for trunk side connection mechanisms between clusters. I've got a lot of additional functionality with SIP. I not only get that, I get presence. As long as I, have a subscribe CSS, and my SIP trunk security profile allows got rerouting out of dialog subscribe CSS all set. My SIP trunk security profile allows the various things that are needed, like the refer out of dialog and present subscription and the unsolicited places header. So as long as I allow all those, and maybe you want to on some, maybe you don't, but just assuming that you have a fully trusted environment with a SIP trunk, I can support presence between clusters. I can support really a lot of additional functionality, and don't have to globalize things or add plus on calling and called. Those remain. Everything becomes a lot simpler. So SIP is really the way forward.